Hello everyone. In this video I'm going to examine digital certificates and explore certification authority. I will create digital signatures. I will use GNU Privacy Guard to create and manage asymmetric key pairs. And finally I will encrypt and decrypt files using asymmetric key encryption. First, I will examine a personal certificate that was automatically created when I encrypted a file in the last lab. We'll go to the start menu and then type in MMC. That will open Microsoft Management Console. And from the file menu, I will go to add remove snap-in, and then from the available snap-ins, I will select certificates and then click on add my user account and finish. And then click on OK. Now I will expand certificates current user on the left side and select personal and expand it and then select certificates. I can see that a certificate was already created. I never created this certificate manually, but when I encrypted this file in the last lab, this certificate was created. Now I will double click on this certificate to see the details. I can see that the certificate was created on February 25, 2023 and it is valid until 21/23. If I go to the details tab, then I can see that the certificate used SHA-1 hash algorithm. It's using RSA public key algorithm with 2048-bit key, and you can see many other pieces of information about the certificate on this page. Now I will copy the thumbprint of this certificate to compare it later with other thumbprints. So I'll copy and then open Notepad. I will keep in a Notepad. Next, I will go to edit properties and then give a friendly name to this certificate. My EFS encrypted file system certificate. And then apply OK. And then OK again. Alright, then I will go to the desktop. So I minimize Microsoft Management Console, minimize Notepad, and then on the desktop I will create a new folder. I will name it as EFS folder. I go to the properties of this folder, go to advanced, and then select encrypt contents to secure data, and then click on OK, apply, and OK. Now I will go back to Microsoft Management Console and I will refresh this window, go to personal certificates. Even though I encrypted the folder, this time it did not create a new certificate as the certificate already exists. Now I'll go back to the desktop and go to the properties of EFS folder and then advanced, and then I will go to the details. I see the users who can access this file. It has a certificate's thumbprint. If I compare this certificate thumbprint with the previously copied value of the thumbprint, I can see that the thumbprint of the certificate that was created when I encrypted this file and the thumbprint of the certificate that is attached to this folder, they are the same. Okay, so I will go back to Microsoft Management Console, go to File, and then Save As, Certificates, and then Save. Alright, so I'm going to close this notepad, and I don't need to save it. Next, I'm going to examine certificates. I will determine which cryptographic algorithms are being used by the certification authority and the expiration date of a certificate. I am already in Microsoft Management Console. I'm going to expand Trusted Root Certification Authority and then go to certificates. I can see a number of certificates there. If I look at Microsoft Root Authority and double click it to see the detail, I can see that this certificate was issued in 1997 and has expired in 2020. If I go to the details of the certificate, I can see that it used MD5 hash algorithm for signature, and it used RSA algorithm for public key 2048 bits. Alright, I'm gonna close this certificate and then I will go to Microsoft Root Certificate Authority, this one. See the detail. This certificate was issued in 2001, has expired 2021. If I go to the details, I can see that it used SHA-1 hash algorithm for signature, and it used RSA public key 4096 bits. I will close this one and then I will check another Microsoft Root Certificate Authority 2010. This certificate was issued in 2010 and is valid until 2035. So this certificate is still valid. If I go to the details, I can see that it is using SHA 256-bit algorithm for hash function. And if I go to the public key, it's using RSA 4096 bits. Okay, so the number of bits has increased. I'm going to close this one. Then I will check Microsoft ECC Product Root Certificate Authority 2018. This certificate is valid from 2018 to 2043. If we go to the details, I can see that it is using the hash function SHA 384-bit, and for public key it is using ECC algorithm 384 bits, and so on. So I'm gonna close this certificate and then close this Microsoft Management Console. I will save it and close these properties dialog boxes that I opened before. Alright, now I'm going to open Microsoft Edge as a browser and then open Google website. So here, as you can see, there is a lock right beside the URL. This represents that the site is secure and it has a digital certificate. So click on the lock and then select connection is secure, and then select the certificate by clicking on the certificate icon. You can see the information to which organization the certificate was issued, the issuing authority, validity, in other words, when it was issued and when will it expire. Okay, so if I go to the details tab, I can see similar type of information but in more detail. I can select any of these items. for example, certificate signature algorithm, and I can see SHA 256 with RSA encryption. I will scroll down further and I can see that there is a certificate revocation list distribution point or CRL distribution point. If I click on it, then I can see the URI of this revocation list. I will copy this path or location, and then in the browser new tab I will paste this, and it downloaded the file. I will open the folder and I can see the revocation list is here. Next I will open command prompt, and then go to the download folder. If I see the file list, I can see the revocation list file is here. I will use certificate utility CERTUTIL dash dump and then space the name of the file, which is MOVD, and then I will press tab to autofill the rest of the file name and then press enter. Okay, it did show the revocation list. If I scroll up, I can see the certificate that has been revoked and on which date the certificates have been revoked and so on. To see this list page by page, I can reissue the command, but this time I'm going to use a pipeline and then more. So it shows one page at a time, and I can go to the next page by pressing on the space bar. I'm going to quit by pressing Q on the keyboard, and I will exit from this command prompt. I can close this. If you want to see the certificate from Google Chrome, so I'll open Google Chrome and then go to a website such as google.com, and I can see there is a lock icon right beside the URL. So click on lock. The browser is not refreshing. When I click on lock, I can see that probably a menu is opening, but because of the display setting I cannot see the menu. So I will go to the host computer and go to Google website. So this is a browser in my physical machine. Click on the lock icon and then I can see that connection is secure. Menu item, you select that one and then click on certificate is valid. It shows the information about the certificate that I saw in Edge. Also, I can go into detail and see all the detail. To see the revocation list here near the bottom of this window, you can select CRL distribution points and then select this URL, copy, go to browser, paste, and that will download. After that, you can use the same command from the command prompt to see the certificate revocation list. Okay, so I'm going to cancel this, I'm going to close this one, and I'm going to close this browser. Next, I'm going to create digital signature and use it in Microsoft Word. I will create a self-signed digital signature. I will need Microsoft Word for that. However, my Windows 10 virtual machine doesn't have Microsoft Word. So I'm going to use my host computer or physical computer for this part of the video. If you have Microsoft Word, then you will have a self-cert.exe file, and the file location can be different depending on which version of Microsoft Word you have. For example, if you have Microsoft Office 365, your file location could be program files and then Microsoft Office root Office 316, or it can be program files x86 Microsoft Office root Office 16. If it's Office 2019, then it can be here. I got this information from Microsoft website. However, I found this information is not exactly correct. I'm using Office 365, and if I look at my program files and then I go to Microsoft Office, there is no root here. I'm using Office 365, but root is not here. I can see Office 16. I will open this. I need self-cert.exe file, so I will search self self-cert.exe. This is the file. So basically I found the location of this file, which is this one. I will copy this location. If you can't copy, you can note where exactly the file is. Okay, and then I need to run this self-cert exe file. So I will double click to open it, and it was opened here. I will use my name for this certificate and then click on OK. It shows that the certificate was created successfully. I click on OK. Now I'm gonna start Microsoft Word on my host computer. Here it is. I will maximize it. If I go to Insert menu and then near the date and time and object icon, there is an item called signature line. I will click on signature line. I will type in the signer name, so signer title. I will keep it optional. So I need to fill up the email address. I will type in any email. So abc at, let's say, mail.com. This is a fake email address, so I'm gonna use this for now and then click on OK. I can see a cross line here appeared, so that means the certificate has been created. Next, I'm gonna save this file, so I'll go to File and then Save As, and I will save the file here. Let's say test signature, test sig, and then save. Okay, now I'm gonna sign here by double clicking on the signature block. I will type in my name and then click on sign. Do you want to use this certificate? Yes, and then click on OK. As soon as I put the signature, the document has been marked as final, so editing is kind of prohibited, or if I edit anything in the file, this signature will not be valid anymore. Okay, so I'm going to click on edit anyway, and then editing will remove the signature, as you can see, which means if I modify the file, then it's not the same file anymore, and it will remove the signature from the file. So if I click on yes, then it removes the signature that I put before. So if I send this file to someone else and he modifies the file, then my signature will not be valid anymore. Okay, so I'm going to put back my signature again and then sign. Yes. Okay, the file has been marked as final. So I'm going to close this file and then open the file again. I can see that the signature is still valid. I can see the signature and it shows the information about the signature. So if this document is edited, then the signature will be automatically removed. All right, I'm going to close this. and I'm gonna close this window as well. Remember, the location of the self-cert.exe file might not be exactly as it shows here, so explore around these folders and you will find self-cert.exe file. In this part of the video, I'm gonna first configure GNU privacy guard key pair and use them to encrypt and decrypt files. I will open terminal and then use gpg -gen-key to generate a key pair. If you're using gpg for the first time and it shows the command not found or a message something like that, then make sure you update and upgrade your Kali Linux operating system. Okay, so press enter, and then I will create a key pair for myself. So I will say, and then a fake email address at mail.com. I will confirm by pressing O on the keyboard, which is for OK. Use a passphrase. Okay, the private key and public key or secret key have been created and signed. And this is the information, the expiry, and so on. I will export my public key by using gpg -armor-export, and then the email address I used, which is abc@mail.com, and then I will save it in a file, the key.gke, and press enter. If I see the list of files, I can see the key file is right here. I can see the key pair by using gpg-fingerprint command. Okay, next I'm going to create a new user so that I can encrypt a file and send it to the new user, and the new user can open it by using his or her private key. So I will create a new user and create key for the new user. I will use the command sudo user-add, and then we'll create a home directory. Username is student, and I need to give password for my account. Okay, the user and a home directory has been created, but the user cannot log in until a password is assigned to the user. So I will use passwd command for the student account. Right, and give the new password. For the new user, a password has been set, a home directory has been set. Now the user need to have some privileges, so I will put the user in the sudo group. To put the user in the sudo group, I will use the usermod command, usermod, and then append a group. Sudo is the group name with the user student. Okay, I will also assign a bash shell to the user. So sudo sh/s bin bash student. All right, now I can log in as this user by using su command, su and then dash student, password for the student account, As you can see, the prompt has changed to student, so I'm logged in as student right now. Now I will generate key for the student as I'm logged in as a student. So sudo gpg gen key and password for the account. The real name I will use student test. Then for the email address I will use test@student.org. Okay, and confirm by pressing O on the keyboard. You need a passphrase and confirm the passphrase. Alright, the public key and secret key or private key have been created for students. Now I'm gonna export these keys in a file, sudo gpg armor export, and then the user is test@student.org, the email of the user actually, and then I will send this into home directory student, and the file name is studentkey.gke. Okay, I can see student's key by using sudo gpg fingerprint. Next, I will exit from student and go back to my account by exit command. So I'm logged out and I'm back to my account. Now I will import the public key from the studentkey.gke file, gpg import home studentkey.gke. that was the file name, and the public key has been imported. Okay, next I'm gonna edit and verify, so I will use gpg -edit key, and then the email address of the student, that is student.org. Sorry, error in the command gpg, there you go. Okay, now I'm in the edit mode. As you can see, the prompt is gpg. Next I'm gonna use fpr command. It shows the key I created before. Okay, so it has been verified. Now I'm gonna sign and then confirm by pressing Y. I need to put the passphrase that I used when I created the key. So it has been signed. Now I'm gonna exit from the edit mode by pressing the Q key on the keyboard and save changes and Y, yes. If I see the list of keys, gpg -list keys, I can see that my own key as well as the student's key. Next, I will create a simple text file using echo command. This is the original, and I will name the text file as plain.txt. Okay, if I see the list of files, I can see that the plain.txt file has been created, and this is the content of plain.txt. Now I will encrypt this plain.txt file. So I will use gpg recipient. Recipient is student, and the email address was test@student.org, and output is encrypted.jpg, and the input file is before the input file name I have to use encrypt, and then the file name plain.txt. So plain.txt file will be encrypted by using the public key identified by the email address, and it will generate the encrypted file encrypted.jpg. So I press enter. Sorry, spelling mistake in output, OUT. Alright, the file has been created. If I look at the list of files, as you can see, it is encrypted.jpg. I can try to use the cat command to see the content of the file, and I can see it is in a format that is not readable and the information cannot be extracted. Alright, next I'm going to send this encrypted.jpg file to student by simply copying it or moving it to the student directory, as if I have sent it by email or something like that and the student has received it. So I'll use the command move mv sudo mv. The file name is encrypted.jpg, and it will be moved to home student, and the file name will be encrypted.jpg as well. So the file has been copied here, as if the student has received the file and has put in his home directory. Okay, so I will log in as a student now. I logged in as a student. If I look at the list of files, I can see encrypted.jpg is the file that I received. I tried to see the content of the file by using cat command encrypted.jpg. Again, all the garbage characters are unreadable. Okay. Next, I will decrypt it by using decrypt parameter with the jpg command. So sudo jpg, the output file name not encrypted.txt. Okay, and I am decrypting the file encrypted.jpg. So with jpg I'm decrypting the file encrypted.jpg, and as the output it will generate not encrypted.txt file. As you can see, only two files present right now, and after this command I will get this file. Okay, so I press enter and it is asking for my passphrase, and this is the email address of the user whose passphrase must be used. So the file has been decrypted. Okay, if I see the list of files, I can see not encrypted.txt file has been created. All right, I want to see the content of this file by using cat command, and I can see that the original file content has been recovered. Okay, so I created a new user and created key pair for the user, and then I created a simple text file, encrypted it with the public key of the new user, then logged in as the new user and decrypted the file to see the content. And that is the end of this video. I hope you found this video was helpful. Thank you for watching.